All right. What up, mathletes? Whoop, whoop. This is still part one, but it's part two of part one. How about that? We're going to talk about two-column proofs here. So you see this two-column proof, and how a two-column proof works is this. We're going to give you some givens, right? It may be one given. It may be more than one given. In this case, we have the given y plus 2 over 3 equals 3. We're telling you that's a true statement. We want to prove that y equals 7. Now, normally you guys would just carry this out. You would do the math needed, you'd solve for y, but now we're actually going to put it in a proof form, something that you should be able to do. So first thing, you'll see we have the numbered 1, 2, 3, and 4, and I'm going to go through these. So step 1, go ahead and write step 1. And I didn't give you tons of room for these, so I ask your forgiveness for that, but we're going to go through step 1. So step 1, you'll notice down here at 1, we just wrote the given statement, and that's why step 1 is list the givens. And part of that step is draw a diagram if needed. Okay, now what I mean by that is if you look down here at the proof we're going to do in a minute, this is already drawn for you, but sometimes you need to draw a diagram to help label things and figure it out. So, awesome. So after we've listed the given, and notice we even label it given under reasons. So we draw this, it's called a two-column proof or a T-chart. We draw this nice little T, and on the left side we label it statements, on the right side reasons. And we start by giving our given, and then we label the reason is it's a given. You have to actually label that. And notice it says 1, and it's kind of hidden right there, but it says 1 as well. All right, let's look in 2. So what is 2? So we write down step 2. Step 2 is create a deductive argument. What do I mean by deductive argument? Well, I'm talking about, well, let's actually look at that. Now, I'm not asking you to write this down, but a deductive argument is an argument that guarantees the truth of the conclusion, provided that its premises are true. Okay? So basically, we're going to create a step-by-step argument here using postulates, because we accept postulates as true. So if we can use a postulate to prove each step or a property, then we're going to state that this ultimately is true. Okay, create a deductive argument. And then we're going to link the given to what you're proving. So we're going to link the given to what we are proving. So we're going to take this given and we're going to use it and work it down until we get to what we're going to prove, which you see we do right here, or it's going to be a process in between. All right, now step 3 is actually over here. And for step 3, and let's just look, before we do that, I want to look at step 2. What do we do to solve this? What would we normally do? We'd multiply both sides by 3 to get rid of the denominator. When we do that, we're left with y plus 2 equals 9. And then we'd subtract 2 from each side to get y equals 7. That's simple. We've done that before. But now we've got to give it a reason. And that's what step 3 is. Step 3 is justify each statement. That's the part we're not used to. And what do our reasons include? Reasons include. So things we can use for our reasons are definitions. So anything that's defined, we can use that, a definition. We can use postulates. Eventually, we'll start using theorems. It's like a stronger postulate. And we're also going to be using, as we've already seen, properties, which is really what we use a lot of here. And you're going to go out of the box a little bit. That's okay. So definitions, theorems, postulates, and properties are what we're going to be using for our justification. You'll notice when we multiplied both sides by 3, what is that called? The multiplication property. We just use the multiplication property. It basically says As long as I do it to both sides of the equal sign, we're good. Let's take a look back at the multiplication properties right on here. If A equals B, then A times B equals B times C, right? As long as I multiply each side by the same number, okay, then we're good. So I said if X equals 3, then 5 times X equals 5 times 3, right? It's the same thing. Okay. And then our last, what do we do right here? After we did that, then we solved it. Now notice we solved it. And in solving it, that's called substitution, because now we're saying y plus 2 equals 9. That's substituting. We're substituting the 9 and the y plus 2. All right, last. What do we have here? We're going to subtract 2 from both sides. That's the subtraction property of equality, which tells me as long as I take the same number from each side, it stays equal. Okay? And step 4, so our last step in these two-column proofs, is state what it is that you are proving. So state what it is that you are proving. The last step of any proof should be writing down what you were told to prove. We were told to prove y equals 7. Our last step is y equals 7 through the subtraction property. All right. Again, pause this if you need to finish writing it down. We're going to go do an actual proof, and it's going to use some extras in it. So you'll notice in our extra section, you'll see several things here. But what do we have here? We have Q is the midpoint of PR. Well, let's go look at what a midpoint is in our toolkit. Let's look at that definition. Definition of a midpoint is the point that divides the line segment into 2 equal parts. That's important. Notice we want to prove that PQ equals PR. So we've drawn this diagram right here. We're saying Q is the midpoint, and we want to prove that PQ is equal to PR, that those lengths are congruent, or is congruent to QR, right? Okay, so it's going to feel kind of weird, some of it, but we're still going to do it because we're learning. We have possible choices here. So what's the next step we want to do? If we're telling you that PQ is the midpoint of PR, I'm telling you their lengths are the same. Do we see anything that says that? Yes, PQ equals QR. And how do we know that PQ equals QR? Well, we've already used this. We can cross that out. We actually used, let's go look at our extras again. How did we even know that's true? Because we know a midpoint by definition is the point that divides the line segment into 2 equal parts. So that's the definition. This is my shorthand for definition of a midpoint. And then our last step is our proof. Look at that. It says PQ is congruent to QR. How can we do that? Well, let's go back and look at extras. What does it say about being congruent? It says congruence is the same shape and size. Well, guess what? We just proved they're the same size. Therefore, PQ is congruent to QR. Why? Definition of congruence. Look at that. Now, I also added in our extras section, I wanted to add in the betweenness of points. We didn't use it, but our betweenness of points is just that it says if you're point B in between points A and C, the length of AB plus BC equals AC. In other words, what are we saying here? If Q is between P and R, then the length of PQ plus QR is equal to the length of PR. All right, but we didn't need that for this, which is why we had some extras there. So look at that, short little proof. But now that we've proved it, guess what? We have now just officially proved the midpoint theorem. And here's what the midpoint theorem says. Notice we have this extra box right here. The midpoint theorem. The midpoint theorem says this. It says, if M is the midpoint of AB, of segment AB. Then we can say that segment AM is congruent to segment MB. And to draw that, it would look like this. And we're saying these segments are congruent. So the cool thing about proofs is once you actually do a logical proof, you never have to prove it again. It is accepted as a fact because we proved it. And we didn't just prove it using numbers, we proved it with letters, which means it works for all numbers. All right, this is some thick stuff we're getting into, guys. So we're going to get through this. It's going to take time, but welcome to the world of proofs. With that said, peace out.